In 8.5, we're learning about two types of variation functions. So in number 1, we are asked to find x times y and y divided by x for three different ordered pairs. For -1, -10, x times y would equal 10. For 2, 5, x times y also equals 10. And for 5, 2, x times y equals 10 again. Now we have to do the y divided by x column. -10 divided by -1 is positive 10. 5 divided by 2 is 5 over 2. And then we have 2 over 5. So notice that x times y is always the same, but y divided by x changes. So whenever x times y is the same for every ordered pair, that is called an inverse variation. For number 2, we're going to do the same thing. So x times y for -3, 6 is -18. For 1, -2, the product is -2. And for 4, -8, the product is -32. 6 divided by -3 is -2. -2 divided by 1 is -2. And -8 divided by 4 is -2. Alright, when the quotient is the same for every ordered pair, that is called direct variation. So we'll talk about direct variation first. The formula for direct variation is y equals k times x, where k is a constant. So you need to use this formula if you are asked to write an equation for a direct variation. Now, if they're not asking you to write an equation, if they're just making you solve for either x or y, then you could use another equation. It's a shortcut, because with this equation you don't have to find k. So the way to get the other equation, solve for k in the equation that we just wrote. So in this same equation, k would equal y divided by x. So then the shortcut equation would be to just take any pair of coordinates and divide them, because looking at the example in the top right, the ratio will always be the same. So if you use this blue equation, you don't have to solve for k, and it's a faster way to solve for whatever they're asking you to solve for. The graph of a direct variation will either look like, so those are my axes, the graph will either look like this, or if there are negative x coordinates going with positive y coordinates, or vice versa, then the graph will look like that. So straight line through the origin is a direct variation. Right, so for number 3 and 4, they are not asking for an equation. They're just asking us to solve for either an x or a y coordinate. So we can use the shortcut. So for direct, whenever it says direct, you can do y1 over x1 equals y2 over x2. I usually don't even bother with the subscripts. When I see y varies directly as x, I just write y over x, and then I equal it to another pair. Okay, so y varies directly as x. Y equals 10 when x equals negative 6. Find y when x equals 3. So we cross multiply. Negative 6y equals 30. So y would equal negative 5. For number 2, y varies directly as x again. So when y equals 3, x equals 10, or actually x equals 12. Find x, so we're solving for x this time, when y equals 4. So we cross multiply again. So diagonally, 3 times x equals 4 times 12, which is 48. So x equals 16. Alright, so you'll notice that direct variation, unless there are negatives involved, direct variation means as y goes up, x goes up. And as y goes down, x goes down. Generally, inverse variation is going to mean that as x goes down, y goes up. And as x goes up, y is going to go down. Unless you have some negative coordinates involved, then it gets a little more complicated. But generally, as x goes up, y goes down for inverse variation. So they go opposite directions. So the formula is y equals k over x. And you need this formula if you are asked to write an equation relating the two variables that are inversely related. Then you'd have to solve for k and put that in your equation with y and x. Now, if they're only asking you to solve for y or for an x, but not asking you to write the equation, then you could use a shortcut. So the shortcut would be, like last time, solve for k. So from that equation, k would equal y times x. And then your shortcut equation would then be y1 x1 equals y2 x2. The graph of an inverse variation will usually look like that, unless there are negatives involved. That is, negatives going with positives and vice versa. In that case, it'll look like this one. Okay, so for number 5, they say, if y varies inversely as x, so as soon as I read that, I know I'm going to be multiplying y and x together. And I don't even bother with the subscripts. Y varies inversely as x means y times x equals y times x. Y equals 10 when x equals 6. Find y when x equals 3. So we have 60 equals 3y. Divide both sides by 3 and you get y equals 20. Number 6, we see the same words to begin the problem. Y varies inversely as x means y times x. Y equals 5 when x equals negative 15. Find x, so we don't know x, when y is 3. So 3x equals negative 75, which means x equals negative 25. You also could have reduced so you don't have to deal with big numbers. Like from this initial step, we could have just reduced, so 3, negative 15. We'll change the 3 to a 1 and the negative 15 to a negative 5. And then from there you can see that x equals negative 25. Okay, on number 7 they tell you that the distance you travel between cities varies directly with the length between the cities on a map. So that makes sense because direct variation means as one goes up, the other goes up, as long as you're dealing with positive numbers. So if two cities on a map are further apart, the actual distance would be further apart. As the distance on a map decreases, the actual distance between those cities would also decrease. So a map of Illinois is scaled so that 2 inches represents 15 miles. Write a direct variation equation. So you're going to have to use the formula with k whenever they ask you to write an equation. Direct means y equals kx. When they ask you to write an equation, you need to have y and x in your final answer. Okay, so let's plug in. So we need to solve for k first, but then we want our final answer to have y and x in it. So we're going to plug in for y and x to solve for k. So I'm going to let the inches represent x and the miles represent y. So I'm going to plug in 15 for y. So it looks like k equals 15 over 2 or 7.5. Your final equation should have y and x in it. So you plug that in for k, and then you change y and x back to y and x. That's the answer to part A. How far apart are Chicago and Rockford if they are 12 inches apart on the map? So we're going to plug in. Remember, inches, we made x, so we're going to just plug that in for x. Y equals 7.5 times 12. So the answer is 7.5 times 12 is 84 plus 6 should be 90. 90, and the units are miles. So on that problem, I somewhat arbitrarily assigned inches to be x and miles to be y. If I had flipped it the other way around, that would have been fine. So it doesn't really matter which one you make x and which one you make y, as long as you are consistent when you plug in later in the problem. Okay, the maximum number of songs that a digital audio player can hold depends on the lengths and the quality of the songs that are recorded. A song will take up more space on the player if it is recorded at a higher quality, like from a CD, than at a lower quality, like from the internet. So they don't tell us, but I can tell this is an inverse variation because if you think about it, direct means as one goes up, the other goes up. Inverse means as one goes up, the other goes down. So as the song quality goes up, the file size will probably go up, meaning the number of songs you can store will go down. So this is an inverse variation. Okay, so we have a device that has 2,400 megabytes of storage. Write a function that represents the number of songs the player can hold. Okay, so we know it's inverse, so we're going to use y equals k over x. And we have to use the formula with k because they ask us to write a function. Okay, so we're actually going to get away from the formula a little bit. If your device can hold 2400 megabytes of storage space, then the number of songs it can hold is 2400 divided by whatever the average size of the songs is. So we'll call it the average size of the songs. We'll call that X. So then the number of songs it can hold is 2400 divided by X. So that was more logic than it was using a formula. Okay, suppose the average file size for a high quality song is 12 megabytes. And then for a low quality song it's 8 megabytes. Determine how many more songs the player can hold if they are low quality than if they are high quality. So for the first high quality songs, we can hold 2400 divided by 12. So that's 2 and then 2 zeros after it. So if we use 12 megabyte songs, we can hold 200 songs. If our songs are 8 megabytes each, then we can have 300 songs. So then the question asks, how many more songs can the player hold? Answer would be 300 minus 200, so 100 songs more.